All right, so we're going to continue this. What is this? 2 something? 2-1? We just started this chapter, didn't we? All right, so we did a thing called relations on whatever day it was. Was it
Friday.
Was it did we? No, it was Thursday. It's probably Thursday. All right, because we didn't have class on Friday because we had the pep rally. So let's talk about what that is. Remember what a relation is? Just it's basically a what? It's very simple. Any relation is a what? Or an. I should say an. It's an ordered pair. That's right. What? No, you're going to watch this and you watch the first lesson at home. Gio. Just, you're in class now. Watch what we do now. Take notes. And then tonight, you can watch the first part on YouTube, which you should have already watched. All right. Right. Doesn't matter. Thank you, Simone, the voice of reason. All right, here we go. A function. Here's what a function is. Let's write this down. Oops. A function. It's a relation, but it's a certain type of relation. So it is going to have ordered pairs in it. All right. I don't usually write down definitions all that often, but this one I think it's important to. So write it down. Gio, you got nothing on your desk. You're just sitting there with nothing on your desk.
Write what's on the board.
I don't have enough room for the first lesson.
Gio, open my paper. Give another piece of paper.
I'm just gonna rewatch it tonight. Oh my goodness. I can watch one and then watch these.
Gio, you might actually like these.
Stop it. Stop.
Part 8 and I can watch part 2.
I'll give you a cookie.
All right, is the element of the domain is paired with, this is why I don't write definitions down because it takes too long, is paired with. Now here's what, oh, come on. Should have started this computer over again because it's dragging. Here's the key. With one and only one, kind of emphasizing one and only one element. Now, you may not really understand after this definition. I completely get it. But at least we'll have it. We can go back and refer to it once we explain what a function is. All right? This is what they do. They do this circle thing, and they put numbers inside of a circle just to show you that there's a relationship between them. So this is, we'll call this relation E. All right, this is just how they do it. They actually put 2 circles, or ovals in this case, and then they stick some numbers in here, and let's see, -3, 1, and 5. These numbers really don't make much difference. And here's what they do. I just want you to see this because you'll see this in the book, and I want you to understand what they're trying to do. So what they're doing here, this is relation E. You want to decide, is it a function or not? So does it fit the definition? So here's the definition. It says a relation in which every element of the domain. Which one of these circles is the domain? The first one. Well, this whole thing is E. All right, it's not just, it looks like this is the only thing that's E. This whole thing is considered E. So it says, in which every element of the domain, this is your domain right there, -1, 1, 3. Okay, what's your range then? -3, 1, 5, right. It's basically, they're just ordered pairs, all right? I don't really know why they do this whole circle thing. Maybe they think it makes it pop out a little bit more to you and you see it a little bit better. But we will look at them as ordered pairs as well. But this is what they do, all right? So they say that -1 is paired with, right, there's in the definition, it's paired with -3. And then 1 is paired with 1, and 3 is paired with 5. And a lot of times, well, I think always, they put arrows here. Oops. I'm going to have to restart this thing before the next class because it's starting to drag again. All right, so here we go. So -1 is paired with this number. +1 is paired with a number, and +3 is paired with another. So says a function, we want to decide if is it a function or not. And that's what we're going to do a lot of times. Okay, they're going to ask you, is this a function or is it not a function? That's a big question they love to ask when you start getting into upper level type of math. This is probably something you did not talk about in Algebra 1. Okay, you know how normally I say, oh, you probably did this in Algebra 1, but here it is again. This is probably one thing that you probably did not talk about in Algebra 1. So this is kind of like an Algebra 2 topic now that we're almost done the first marking period. All right, it says it's a relation in which every element of the domain is paired with one and only one element of the range. Is that happening here?
Yeah.
This is only paired with one. This is only paired with one number. This is only paired with one number, okay? If it was not a function, then this would be paired with two numbers. Do you see that? So this would be not a function. The first thing I wrote would be a function. Why is this not a function? Because this domain, is it paired with one and only one range? No, this is paired with the number 1 and it's paired with the number 5. That's not one and only one element of the range. So this situation right here would what? Is it a function or not a function?
No.
It's not a function because it's paired with two different elements of the range. Okay? But that's not what this problem said. This one's just like that. So, is that a function? Yes. All right. Here's another one. This is, and that E doesn't necessarily have to go like right. I can put that E like right here. So this is the E relation or the E function. All right. And then now we have another function. I'm just going to put the numbers in and I'll put the circles around it. 1, 3, 5. Again, I don't really know the significance of the circles, but I don't know. It just kind of groups them together so you see it a little bit better. I think that's probably the only reason they do that. And here's put a circle around that. In the book, they look like real circles, not ovals, I think. All right, so here's what they do here. All right, so this is what they tell you, okay? I mean, you can't figure, this stuff that I put with the arrows, you can't figure that out on your own. They give this to you, all right? So they say, this number is paired with this one's paired with this one, and that's what I'm showing you right now. So, like, or for instance, I'll tell you what, let's go back to this. Since I said we could write them as ordered pairs. How would I write this as an ordered pair? The -1 is paired with what? The -3. Oops, come on. I'm going to complain about this all class, I know, this dumb marker thing. All right, so -1 goes with -3, then 1 goes with 1, and then what? 3 goes with 5. So how do you decide if it's a function or not? You look to see if the x's are paired with more than one y. Do you hear me? All right. So look, -1. What does it go to? It just goes -3, doesn't it? It doesn't go to another number. So what if I had -1 goes with 5? Then that's not a function. Right, exactly. It's not that it won't work, it's just it's not a function. They just don't consider it a function. Everybody with me on that? Because -1 goes to -3 and -1 also goes to 5. Goes to a different number, correct? All right, so that would be not a function. That would be a function. Same thing with this. But I'll do the arrows since that's what they do, and you'll see this in the book, so just so you get used to it. So this one goes with 3. I'll just draw it by hand. 3 goes with -1. Now watch this. 3 also goes with 2. I could stop right there, couldn't I? 5 goes with 4. Is that a function? Why not? Because of what? What reason is this not a function? Because 3 goes with what? 2 different numbers in the range. Remember, each domain can only go to one unique number in the range. Okay? So 3 goes with -1 and it goes with 2. That's enough right there to say that's not a function. We good? All right, I know it's weird, but that's what we just have to do. We just got to know whether it's a function or not. Again, I could have written this as an ordered pair. So if I was to write this whole situation as ordered pairs, what would I write? 1 goes with what? 3. All right, and what's another one? 3 goes with -1, and 3 also goes with 2, and then 5 goes with 4. So what if they didn't give you all this with the arrows and stuff like that, and they only gave you the ordered pairs? All right? Could you tell if it was a function or not? Yeah, well, look at that. There's a 3 here and there's a 3 here. 3 goes to -1, and 3 also goes to +2. That's enough to say that it's not a function. All right, let's do another one. And I'll show you where it kind of makes sense graphically, too, once we do this. So here's one more. This is -2, 0, 2, and 4. All right, we'll put that in a circle. And then the range only has 1. All right, and everything, let's change colors. Keep the same, come on, click. There we go. All right, so that goes to 4, that goes to 4.
You had a 1:20 dismissal, the bus is leaving at 1:40 at the lobby.
All right, there we go. Now, what about this? Is this a function? Yeah, even though they all go to the same range, right? This domain, see how they're all different numbers right here? This goes to a domain. Here's a different, I'm sorry, it goes to a range. This domain right here is a different number than this. So they only go to one range. This just goes to 1, this just goes to 1, this goes to 1, and this goes to 1 in the range. Even though they all go to the same number, that's fine. You just can't have one number in the domain going to 2 different numbers in the range. You hear me? It gets confusing. It really does, because a lot of people will look like this, and I got heads down on the desk. Why do I have heads down on the desk? Sure not going to learn anything that way. I know. I'll watch the video. I'll watch the video. I get it. But he won't watch the video. All right, so that's it. So yes, is this a function? Yes, it's a function. So here's how I'd write the answer to all of these. Say, yes, it is a what? Function. I would do this because it just, I don't know. You know, in English class, they always say, what do they say? Write your answer as form of sentence or something like that. I don't know. In a complete sentence. Yeah, so it's better to write it like that. All right, enough of that. Let's talk about this. So what if, now we'll wait for the example to do what I was going to do. I'll do this first. There's a thing to determine. So if you looked at a graph, there's an easy way to tell if it's a function by looking at the graph. All right? And I'll show it to you here. And let's draw a line. Let's just draw a regular straight line. Well, they're all lines are straight, but okay. I want to determine, is this a function or is it not a function? All right, you're like, oh, okay, Mr. Hamrick, I got the whole circle thing with the lines going to it and all that, but now you threw a graph in here. But remember, what is a graph? It's made up of a whole bunch of what? A whole bunch of points, that's right. Okay, so you got a point right there, right? You got a point right here, here, all over the place. I could keep doing this all day long, right? Let's take a look. Remember, every x can only go to one y. Is that situation true here? Is there anywhere that there's a number on the x-axis that goes to 2 different y values? There's not, okay? So what is this? It's a function. So what we do is this. It's called the vertical line test. It's very simple. It's called the vertical line test. So if we drew a vertical line anywhere on that graph, see the red? I can draw a vertical line anywhere on here. I'll just try to get it to go through the dots, the points, okay? Will it only hit at one point? If it only hits at one point, then it's a function, okay? But I need to be able to draw a graph anywhere on here. Well, it only hits one line there, right? Or 1 point. Only hits 1 point on that graph. Only hits 1 point on right there. Any time you draw a vertical line through that red graph, that red line right there, you can only hit the graph at one point. You're like, well, of course. Doesn't that work with every single graph? Because everything that I've done so far in Algebra 1 maybe, the graph is just a straight line. But not all graphs are straight lines. I'll show you an example. So let's make the graph thing. We're not going to talk about how you get this graph right here. We will later on in the year. Okay, we're not going to talk about it right now, but there are graphs that look kind of strange. And you might get a graph that looks something like this. Okay? Is that a function? Why not? What test are we going to apply to it? The vertical line test. So that means we should be able to draw a vertical line anywhere on this graph and it only hits at one point. Well, maybe that's true right here. Would you agree? You're like, oh yeah, it only hits at one point right there. But can I draw a vertical line anywhere and it only hits at one point? No, because as soon as I do it right here. Okay, so look where it hits. It hits right here.
JV and varsity, you have 120 dismissal.
What?
You're leading
Do you have a math question? Do you have a math question?
Soccer, you'll be dismissed at 145.
Pre-cap?
You'll be departing school, upper school lobby at 2:15. Middle school volleyball, you have a 145 dismissal. You'll be departing the upper school lobby at 2:15. Thank you.
All right, that was quick. All right, now let's take a look at it. I want you to understand why the vertical line test works. Because, everybody listen, up here. So look at this point right here. I don't know, let's make this up. Let's say that's at 3, okay? And this is whatever, I don't know, 7, and this is, I don't know, -3 or something like that, okay? So look at the 3. This ordered pair is what? It's 3, 7, and this ordered pair right here is what? 3, -3. Look at it. Look at just the ordered pairs. This 3 goes to a 7, this 3 goes to a -3. What does that make it? Not a function. Do you understand where that vertical line test comes from now? All right. So if it does not pass the vertical line test, meaning what? How does it pass the vertical line test? If it only hits 1 point. This hits more than 1 point. All right. This vertical line hits more than 1 point. That means this x is paired with 2 different y's. This is not a function. You may see, again, later on in this class, draw a graph again. You may see something very similar to that. Well, it kind of looks similar. Come on. There you go. All right, you may see something like this. Oh, it's supposed to be an arrow. Okay. Not my best picture of this, but it's close enough. Is that a function? Yeah, because I could draw a vertical line anywhere on this graph, right? Draw a vertical line here. How many places does it hit? That red line right there. Only hits one place right there, doesn't it? Okay? I could do this all day long, and it's only going to hit at one place, at one place, at one place. Okay? So, is that a function? Absolutely, because each x only is paired with one y. One and only y. One and only one y. Everybody good? All right, that's easy enough. Example 4, we pretty much talked about it. I'm going to skip that. Let's talk about this. This is where we really get into functions. This is the stuff that we're really going to do a lot of the rest of this year. All right? Let me go back to white. Okay. And this is called function notation. This is how we write functions. This graphics tablet is dragging, and every time I try to write kind of fast, it messes up. So I got to write slow, and I hate writing slow. There we go. That's better. Function notation. Just got it. Oh, see? Try to go too fast. Function notation. So here's what we're going to do. Do you remember you did stuff like this, didn't you? You had problems that said evaluate this if, I don't know, x is -3. Just make that up. Remember these problems in Algebra 1? Yeah, you did plenty of these kind of things. So what'd you do? The math is easy. You just took that -3 and you plugged it in for x. 2 times -3 is -6 minus 1 is -7. Okay, that's fine. I'm not worried about the math part. I'm worried about the notation of it. So what we do now is this is considered a function. Because if I graph that, it would just be a nice straight line, wouldn't it? All right, it would have a y-intercept of -1, have a slope of 2. You could graph that really easy. You could look at it and say, yes, that's a function. So what we're going to do is we're going to take this. Instead of saying y equals, what we're going to do is put it in function notation. And this is what we use. We use the letter, and you don't have to use f, but we use it a lot because the word function starts with f, but you don't have to use f. But what we're going to do, if I could write on here, f parentheses x. This is not f times x. This is not a letter f times a letter x. This is our notation, and this replaces the y. And you're like, well, what was wrong with the y? We got along just fine. Why would you change it to something that looks even more complicated? Well, because this notation is actually going to make something that looks a little bit complicated actually a little bit easier. All right, it's a little more streamlined. This is the kind of stuff that you're going to do when you get not just upper level math. You're going to do it here. You'll do it in pre-calc. You'll do it in calculus forever. Okay, you'll see that all the time. But we say, I'm going to put it in quotation, we say f of, if I could write here, this is driving me nuts, f of x. This is how we say that. Everybody see it? If you have an f and then a parentheses, then an x, we say it's f of x. All right? That's how we say it, f of x. You could have g of x. That's another common one. All right? So you would say what? I just said it. G of x. You could have an h. This would be h of x. All right? So it doesn't always have to be f. A lot of times it is, though. Okay? In math books, a lot of times they say f of x, but it could be other things. So let's just yeah, I just did that as an example. Let's do the actual example in the book. They talk about the independent variable, dependent variable. I'm just going to go on to the example. All right, so here's an example, and all right, it says evaluate. The other one said evaluate, so does this one, but they're going to use that function notation. So f of x equals 3x minus 5. And then it says for the following domain. All right, the domain are your x values, okay? And your range is the f of x. So here's what they do. This is kind of like a multi-problem. It's more than just one question. And then they put the domain in a bracket or in a brace. And there you go. So this is very similar to this thing right here. Y equals 2x minus 1 if x equals -3. But this, we kind of streamlined it a little bit. And we're actually putting 3 values in for x. So this says f of x. These are my x values because it's in the domain. So we're going to take those, we're going to plug it in for this x right there. It means the same thing as that other thing that we did. All right, it just looks a little different. After a while, you'll get so used to this notation, you won't even think about it anymore. All right, so what does that mean? What we're going to do is we're going to find f of -2. Where did I get that -2 from? From my domain, that's right. So if I found f of -2, what do I write? 3 times -2. All we did was just replace the x with -2. All right? And now we just do the work. That should be easy. That's -6 minus 5 is -11. So f of -2 is equal to -11. All right? This is my function. This is my f function. It could be a g function, h function, whatever letter function. Usually they kind of stick with f, g, and h. Usually, not all the time. All right? And then we just do it 3 more times. Now what are we going to do? F of what? Find f of 0. And then do that. So it's 3 times, come on, 3 times 0 minus 5 0 minus 5 is negative 5. And so f of 0 is equal to negative 5. And then we've got one more to do. What do we do here? F of 4. And then you just plug that in. 3 times what? 4 minus 5. 12 minus 5 is 7. Oops, come on. So f of 4 equals 7. Right? Just getting used to the notation. That's all it is. Okay? It's nothing fancy. The math isn't anything you haven't done before. All right? It's just the notation looks a little bit different, a little bit weird. All right? Now what we're going to do is this. We're going to graph a function, all right, which is just like graphing y equals something, right? Y equals mx plus b, all right? You know how to do that? It's the same kind of thing, except it's going to look a little weird. So I hope you're awake. I hope you're paying attention. So we are going to graph. It's this tablet. I just write a little bit too fast, and then it goes nuts on me. We're going to graph this function, and then this is how they write the function. It's kind of strange looking, and this is all new to you. So we're going to put x, comma, g of x. Remember, f of x, g of x, h of x means the same thing. All right, so what is this? This is like our x, and this is kind of like our what in our ordered pair? So like our y, right? So g of x is kind of like y, f of x is kind of like our y, and h of x if you wanted to use that. Now here's what they do. You want to graph the x and the y such that, did we talk about that in this class? Yes. Yeah, the such that, and then here's what they're going to give you. They're going to give you the function. G of x equals negative 1/2 x. And then they put a comma. Now, if I just graph that, that would be easy, wouldn't it? What's my y-intercept? If I was to graph negative 1/2 x, it'd be 0, and then the slope would be negative 1/2. Go down 1, go to the right 2, put a point, connect them, boom, you got your line. But this time, they give you a restriction on the domain. All right? You're not just going to draw a line and put every single point on that graph. They give you a restriction on the domain, and that's what they're going to do right here. I think they put a semicolon. Look in the book. Do they put a semicolon or just a comma? I don't know. Let's concentrate on this, okay? I'm not going to get into that. So look, negative 2 is less than or equal. If this was the end of class and I was finished teaching a lesson, I'd talk about that, but I'm in the middle of a lesson. Oh, that's an ugly brace. Let me try that again. There we go. That's a little bit better. All right. This is crazy looking, all right? But it's really not as hard as it looks. I'll put it that way. So I'm going to put a graph. Now, look at my domain. My domain goes only from negative 2 to what? To 4. So my domain, my x values, can only be between negative 2 and 4. So I'm going to put negative 2 right there. I'm going to put 4 right there. Okay? So those are the only values I'm going to put in here. So when I do my line, it's not going to keep on going forever with arrows on the ends of it because I'm restricted. My x's can only be between negative 2 and 4. So it's not going to keep on going in one direction or both directions. It's going to start and stop. All right? I got 1, 2, 3, 4 heads down. Get your heads up. Okay, this is stuff you've never seen before. How could you put your head down if you've never seen this before? And I'm teaching it for the very first time to you. Anyway, let's do this. If I was to graph, it's a conversation I would have with my CP class. I shouldn't have that with my honors class. So look, negative 1/2 x and then plus 0. So where is the first point I'm going to plot? Right there at 0. And then the slope is negative 1 over 2. So I'll just put it right here. Negative 1 over 2 right there. Okay? Now, don't draw what I'm going to draw because it's not correct. Normally, we would just do this, wouldn't we? Would you agree? All right? That's what we would normally do if you were to graph this thing right here. Okay, y-intercept is 0. The slope is -1 over 2. But what do they tell us? They say that you can only use the values between -2 and 4. So if I go -2, that point right there, that's where your point's got to end, or your line's got to end. All right? It says between 4. So I go over 4. Where am I on this graph? I'm right there. So my line has got to be between this point and this point right here. All right? So I'm going to get rid of that arrow. I'm going to get rid of this arrow because it doesn't keep on going. It has a beginning and it has an end. So I only go from this point to this point right there. Now you can draw that if you want to. That's your graph. All that nonsense looking stuff right there. This is what it means. Again, don't worry too much about this. What does this mean? It just means x, y. All right, so it just says for this domain and this range, the range or the function is -1/2 x. So we just graph it. But it gives you restrictions. It says x can only be between -2 and 4. So on the x-axis, there's -2. There's the point that's associated with it, and that one right there. Now, it says less than or equal on both of these. That's why I put the solid dot. What if it just said less than? Would it keep on going if you said less than? And it'd be an open circle, right? It'd just be an open circle, okay? So you got to look for that. Sometimes one of them will just be less than and the other one will be less than or greater than. So what if they both said less than? This would be open, this would be open. Okay? If this one said less than or greater than, or less than or equal to, and this one just said less than, then this point right here would be open and that would be closed. All right? So make sure, don't just put a line, make sure you put that point at the end, because that point indicates whether it could be equal to that number or not. And that's your graph right there. What do you think? That's not so scary now, is it? At first it was. First it looked real crazy. Like, what in the world are they asking you to do? Well, really, the only thing they're asking you to do is graph y equals -1/2 x, but they restrict you. Okay, you draw the line, but then you can't keep on going forever and ever because you can't use numbers to the left of -2 and you can't use numbers to the right of +4. You can only stay within -2 and +4, and that's what your line's going to look like. All right, well, I did my job. I knocked half of you guys out. Come on. And let's see. Was that it or not? Yeah, that was it. That's it. All right, so you got two things. You got 1 to 22, and that's section what? 2.1a? Section 2.1a. And then you got section 2.1b. Whoops.
What pages?
I don't know. Section 2.1. Just look up 2.1. 23. Oh, I put 34. I changed it to. Did I put 34 on the thing? Yeah, I did. Yeah, that's fine. Just go to 34. I should have had you go to 35, but okay. So it's numbers 23 to 35. Yeah. Yep. Okay, that's it. Make them. Again, make them 2 lessons because I think the first one's just about relations, and then 23-35 is the one about functions. The relation ones should be super quick, super easy. Looks like I gave you a lot of them, 22 of those, but it's not like you got to sit and think about them. I mean, they should be pretty easy if I remember. I don't have it in front of me, but if I remember, that should be super quick. The 23 to 35, a lot of them, you just look at it and say, yeah, it's a function, right? You look at the arrow thing and tell if it's a function. You look at the ordered pairs, tell it's a function. And yeah, that's it. Question? I want 2 separate. I want them separate. They're separate assignments. I'm going to give you 5 points each, right, for each assignment. So make them 2 separate.